Leetcode problem. And now let's try 33. Search in a rotated sorted array. So the problem is given like this. So we are given a array. So some of them, like 4, 5, 6, 7, is sorted in increasing order, and then it goes to 0, 1, 2. It is also in increasing order. So this is did by sorted the numbers. Like for example, this is 0, 1, 2, 5, 6, and 7. And then we just need to rotate this array. For example, the 7 will rotate here, and then 6, and then 5 and 4. And then this becomes 4, 5, 6, 7, 0, 1, 2. What we needed to do is we needed to find a number inside of the array. If we didn't find, we just needed to return -1. We must write an algorithm with O log n. So this means we have to use a binary search. Yeah, for example, this one, we want to find a target 0, so the index is 4. We just need to return 4. This one, we need to find 3, but there's no 3 inside the array, so we need to return -1. And for this one, there's no 0, we just need to return -1. Yeah, and the num's length is like maximum 5,000. Yeah, and also all values of nums are unique. So this makes the problem much easier because all the numbers are unique. Now let me go to the whiteboard first and then go to the code editor to finish the coding. So basically we are giving two lines. If we convert the numbers into line, one line is like this. It is in increasing order. Another line it is this, like here, in increasing order. And this point must be lower than this point. Like this point is A, B, and this point are C and D. So the D must be lower than A because all the numbers are unique. And after rotation, so the D should be lower than A. If we want to use binary search, we have to find some midpoint. So we are going to do like this. So if AB is longer and CD is shorter, so in the middle it should be somewhere like here. So this is M. So here is L and here is R. So in the middle here is M. Then we just need to compare the M point with others. Yeah, so if this M point is bigger than this L point, yeah. If this M point is bigger than this L point, we find a range. So in this range, we need to check where is the target. Yeah, if the target is in these areas, it means we can use a binary search to set the R pointer to M -1. Yeah. So if the point is at the other side, yeah, so we need to shift the L pointer. So the L pointer should be equal to M +1. Yeah, so this is one condition. And another condition is like this. If this AB is shorter and the CD are longer, yeah, so the M may be somewhere here. So here is still AB, and here's still C and D, but CD are longer. Now, if the M point is here, we just need to compare this M. If this M is, so here is the C and D. So if this M is bigger, so this is the L point. As we already know, the B point must be bigger than A. So here we set it as L point. Here, still the R point. If this M is bigger than this L point, we know M must be somewhere in CD, in the CD line. Then we just need to compare the target value. If the target is somewhere between this M and R, yeah, we just need to shift the L pointer to M +1. So we will use binary search in these areas. Yeah. If it is not, we just need to set the R pointer to M -1. So we need to find the target in this range. Yeah, between this line and this line. We continually use binary search until we find one point, such as M is here L pointer equals to this R pointer. Yeah, and then we need to check if we find a target. If we find a target, we just need to return this M. Yeah, here is M pointer. For example, here is M pointer. If we find this point, if we didn't, so the L pointer should L plus 1, M plus 1, so it goes out of the loop. We just need to return minus 1. Yeah, so basically the idea is like we have two lines. One line may be longer and another line may be shorter. First of all, endpoint, and then we just need to check where is the target. If the target is between L and M here, we need to use binary search in these areas. If it is not, we use binary search in these areas. So continually, for each loop, we just make the range half. We just find the half of the range. For example, this is half, another maybe half, and here we also find the half of the range. Continually, using binary search, we find the endpoint. Now let me just go to the code editor to finish the coding. As I said, with two pointers, L pointer and R pointer. So the L pointer should be 0 and R is len nums minus 1. We will use binary search while L less than and equal to R. We find the M equals to L plus R minus L and divided by 2. If we find the nums M equals to the target, if we find some number equals to the target, we just need to return M, and then we need to check. Yeah, if it is not the condition, check the nums. We need to check the target. So if the target is more than and equal to nums L and less than nums M, yeah, here we don't need to equal, because if equal, we just need to return M. So if it is less than, for the first condition, we need to check. Yeah, we need to check if this nums M is bigger than the nums L. If the nums is bigger and equal than nums L, yeah, if this nums L is less than and equal to nums M, it is here. Yeah, if this nums M is bigger and equal to this nums L, yeah, so this is the first condition. After the first condition, we need to go to the second condition. So where is the target? So this is the first condition. After the first condition, we just need to check if the target is between these areas. So yeah, if the target is between these areas, we just need to shift the M point. Yes, so the R pointer should equal to M minus 1. Else, if it is not, so the L pointer should equal to M plus 1. Yeah, and for another condition, we just need to use else. So if the nums M, if nums M bigger, so this is nums M bigger and equal than nums L. If nums M smaller than nums L, so it is here. So if nums M is smaller than this nums L here, so this is our second condition. Yeah, for the second condition, we still need to check if the target. So if the target less than nums R and more than nums M. Yeah, so this is here. If this target is less than nums R and more than nums L, so here is the target. If the target is in these areas, we just need to shift the L pointer. So the L pointer should equal to M plus 1. So the L pointer should equal to M plus 1. Else, in another side, in the left side, so the R pointer should equal to M minus 1. If we didn't find the number, we just needed to return minus 1. Yeah, so basically we are just using a binary search. This is why we can use a calculator in time complexity of O log n. So here we just needed to find the midpoint. If we find the target, we just needed to return m. Otherwise, we put it in two conditions. If it is nums m more than nums l, so it is this condition. It is this condition. Otherwise, we use the second condition. Yeah, because for all the combined me, just run it to check if everything is okay. Yeah, it seems okay. Now let me submit it to check if it can pass all the testing cases.